Alright, welcome guys. Today we're going to be taking a look at lab number 11. I just wanted to do a quick introduction and then show you the simulation tool. Alright, so these simulations can be found at phet.colorado.edu. If you have an iPad, this will not work. My suggestion is you watch the video. I'll go step by step for page 1 today. We'll be doing step by step for page 2 tomorrow. Introduction. Dead things decay into simpler molecules. Radioactive particles decay. Is it the same kind of decay? What does it mean when a substance is radioactive? In this simulation, you will investigate the concept of half-life. So you have some vocabulary you need to define. You can use your notes or the internet to get those answers. And today we're going to take a look at the simulation. So you're going to go to PHET's website, Playing with the Sims, Chemistry, Radioactive Dating Game. Take some time, play with the simulation. Those atoms are radioactive. How cool is that? How many protons does carbon-14 have? How many neutrons do they have? So a quick crash course in chemistry. If you can see right here, we have a carbon atom. We have the atomic number, which is the number of protons. And then we have the atomic mass, which is the number of protons and the number of neutrons combined. 12, take away 6, will give us 6. 6 protons, 6 neutrons. 6 protons, 6 neutrons. On the simulation, you'll click the half-life tab. Add 1 carbon-14 to the play area. What happens to that carbon-14 atom? So, here's the play area. Let's grab one of these carbon-14 atoms. Let's drop it in the play area. What happened? It decayed into nitrogen-14. So what happened to the carbon-14 atom? It decayed into nitrogen-14. Now, do all carbon-14 atoms decay at the same time? Well, let's add a bunch and see what happens. You can see some decayed early, some decayed late. So no, all atoms of carbon-14 do not decay at the same time. Let's add 50 carbon-14 atoms. Click Add 10 5 times. What happens? One, 2, 3, 4, 5. There's 50. Let's take a look at what happens. Alright, so it appears that many of them decayed up front, and then a decreasing amount decayed as time progressed. Let's reset all nuclei. We're going to, using 20 carbon-14s, draw the pie graph for the following times. So let's reset all. Let's pause it, let's add 10, let's add 20. And we're going to draw the pie chart for 5,000 years. So here's the pie chart, and here's where we're going to stop at 5,000. Draw your pie chart. At about 5,000, it looks like we had half as carbon-10, half as nitrogen, half as carbon-14, half as nitrogen-14. So in order to draw the pie chart, you're going to go to Circle Shapes tool, Shapes, find a circle, draw on a circle, and then you're going to use a line to go from one side to the other, because it looked like it was cut pretty much perfectly in half. Using the text box tool, we're going to write C14. Using the text box tool, we're going to write N14. So that's it for 5,000. We'll do the same thing for 10,000. Let's hit play. And we stopped at about 10,000. Alright, I know it's a little late, but that's what the pie chart should look like. You'll draw that pie chart for 10,000. And you'll draw this pie chart for 15,000. There you go. Now we're going to do the same thing, but with 100. So I'm going to clear all. Pause it. There's 100. Okay, I'm going to stop at 5,000. Okay, that's the pie chart you're going to draw for 5,000. That's the pie chart you're going to draw for 10,000. And that's the pie chart you're going to draw for 15,000. Okay, and that was for the 100 carbon atoms. So you should have 6 pie charts drawn at this point. How do the pie graphs of 20 atoms compare to the 100 atoms? Please answer. And generally, does the size of a radioactive sample affect its half-life? Why or why not? And that's it for today. Tomorrow we're going to be taking a look at the second half of this lab and trying to figure out exactly where these atoms come from, where they go, how they decay. All right, thank you.